All right. Well, good afternoon. I know that we weren't expecting to not be in school today, but just so that all you guys know, basically what happened was us teachers in Blount County got our second vaccine shot. So, unfortunately, there are side effects with the vaccine, and many teachers, including myself, had some pretty serious side effects. I had a fever over 101. In fact, I had a fever last night as well. And so they just decided it was probably better to just go ahead and go virtual today. So us teachers are in the building, but that way we don't have to worry about all these side effects while trying to teach. So just a heads up, everybody's fine, but there are side effects. I highly encourage you guys that when the vaccine does come out, it is a good decision to get it. I would absolutely do it all over again. One bad night of fever and sweat and all that is absolutely worth it to know that I'm safe from COVID and I'm not going to be spreading it to you guys or anybody in my family. So this vaccine is 95% effective. So by all means, I encourage you, do not feel bad about the vaccine just because it's got a couple side effects for a day. So that's what was going on. So I'm going to do something a little bit different today. I'm going to go ahead and just teach up here on the whiteboard. So if you would, go ahead and get on Google Classroom, click on the lesson for today. It's lesson 15.2. It's called Constructing or Creating Geometric Sequences. So go ahead and get on that. So creating geometric sequences. We've done arithmetic sequences. You guys are familiar with those. Arithmetic are the ones that are going up or down by the same amount each time. Geometric can be a little bit different. It's going to be more of a ratio. We're going to get into that. But the first thing I'd like you to do is to go ahead and do the bell ringer. There's 3 questions. They're kind of review, see what you guys know. Go ahead and do those, and then we're going to come back. So pause the video, do the 3 bell ringer questions, and then come back. Okay, so on the bell ringer, we've got problem number 1 says, what pattern can be found in the numbers below and what comes next? And it gives us 3, 6, 12, 24, 48, question. All right, so the first thing we want to do is try to figure out what can be the common ratio in this case. So if I look at each of these, you might have noticed that they're going up times 2 each time. So multiplying times 2. So if I wanted to know the next term, I would take 48 times 2. That's going to give me 96. If you're ever not sure what the ratio might be, just take one of the later terms divided by the previous term. So 6 divided by 2 gives you 3. I'm sorry, 6 divided by 3 gives you 2. 12 divided by 6 gives you 2. 24 divided by 12 gives you 2. So you could go that route. All right, so that one's a pretty straightforward one. Go ahead and, if you've not yet, try number 2. And number 2 tells us that we've got this pattern. All right, so it looks kind of similar. So you might notice the pattern that's happening here is that it's being divided by 2. All right, so 32 divided by 2 equals 16. 16 divided by 2 equals 8, so on and so forth. Finally, to get this last one, 2 divided by 2 would give you 1. So that should have been your next term in the sequence. All right, we've got one more. Go ahead and try number 3. Number 3 is the tricky one, so if you've not tried it yet, go ahead, pause the video, give it a shot. All right, so it gives us this sequence, and we've seen some kind of like this before. You'll notice it's going positive, negative, positive, negative, positive, negative, all right? Well, first of all, as soon as we see that, we know it's going to be geometric. We have to be multiplying or dividing it by something for that to happen. So if I took, sorry, the bell's still ringing in front of you guys, aren't you? If I took negative 3 and divided by 1, that would be negative 3. If I took 9 divided by negative 3, that would be negative 3. Negative 27 divided by 9, it's negative 3. You'll notice that each time it's being multiplied by -3. So to find that common ratio, you're just taking one of the later terms, divide it by the previous term, see what you get. All right, so for my last one, 81 times -3 is going to be -243. So there you go. Hopefully you got all three of those. They weren't that hard, but all three of those are examples of geometric sequences. So if you would, let's go ahead and go to the next page and get started on the lesson for today. It's going to be a fairly short one. After the lesson, I've got a Kahoot for you to do some practice. Just as a reminder, there is a quiz over this tomorrow, so make sure that you understand it. If you need to, reach out to me with any questions. All right, so it says on the next page, what is a sequence in math? And the biggest thing I want you to remember is that a sequence is a list of terms in a particular order. All right, and I know that I've talked about this before, but one of the reasons why I think sequences are so important is you may or may not know, I have a big background in manufacturing. My dad owned manufacturing plants. That's what I kind of grew up in. And I was really, really good at manufacturing. One of the reasons I was so good at manufacturing was I'm really good at sequences. So for whatever reason in my life, I've been able to figure out sequences pretty darn well. So there's an example of a sequence. Well, if you want to be somebody that an employer really values, it's not just being able to recognize what the common ratio is, but it's being able to recognize when you come into a situation and you only have these numbers to know what's missing. I can walk into a manufacturing plant and realize what processes they're doing wrong because I can see patterns really easily. So what we're doing here is we're teaching our brains to recognize patterns. In this case, like I said, sequence just means something's going to be in a particular order. As you might remember, there's going to be two different kinds of sequences. We have arithmetic, and then our new one today is going to be geometric. We did arithmetic last week. Arithmetic is a sequence that goes up or down by the same amount each time. The common difference on these are always going to be plus or minus. So I want you to think of plus or minus. If I go 2, 4, 6, 8, 10, 12, I'm going up by 2 each time. That's going to be an arithmetic. For geometric, that's our new one for today, and that's going to be a sequence that has a common ratio. All right, so the key word over here is going to be common difference for arithmetic. The key word for geometric is going to be common ratio. So when you hear geometric, I want you to think multiplication or division. All right, so for instance, 3, 6, 12, 24, 48, 96. I'm multiplying by 2. So multiplication is going to be under geometric. Okay, so you might remember that we had a formula for arithmetic. For an explicit, it said something like f of n equals f of 1 plus d times n minus 1. And we had this equation that we figured out. Well, we're going to have the same kind of thing for geometric. So here's what I'd like you to do. When you go down, let's go ahead and write down what the formula is going to be for geometric. All right, so this is the next part down. So for geometric, we do have a formula. And that formula is going to be f of n, which looks very familiar, equals f of 1 times r, and then raise to the power of n minus 1. All right, so we have a lot going on here. Let's go and draw a couple arrows and label a couple things. So f of n, that's going to be the term that we want to find. So that's the term defined. f of 1, you guys might recognize that. That's our first term. And r, that's going to be our common ratio. Now remember, before we had a common difference when it comes to arithmetic. For geometric, it's going to be common ratio. And we raise it to the power of n minus 1. We're going to do some examples of these here in a little bit, but I just want to go ahead and show you that so that you've got it. All right, so go ahead and go to the next page where it says geometric sequences, example number 1. All right, so let's go ahead and start off easy here and do a couple of practice problems. So it says find the common ratio for each geometric sequence and use r to find the next 3 terms. So it gives us a sequence: 6, 12, 24, 48, and it wants us to tell what r is. It wants us to tell the next 3 terms. All right, so r. So to figure out r, I need to figure out what pattern this sequence has. When it comes to geometric, kind of like we did on the bell ringer, the best thing to do is take one of the later terms and then divide it by a previous term, see what you get. So in this case, 24 divided by 12 gives me 2. So let's go ahead and check that. 6, let's do the opposite. If I did 6 times 2, yep, that gives me 12. 12 times 2, yep, that gives me 24. 24 times 2 gives me 48. So my common ratio is going to be times 2. So all right, multiplied by 2. Next 3 terms, 48 times 2, that gives me 96. Next one after that, 96 times 2. Right here, I don't have a calculator on me, but I believe that that's 192. I'm doing my math properly. And then the next one after that, let's see, be 384. Pretty sure I'm right about that. So for the next 3 terms, we have 96, 192, 384. If you guys have to use a calculator to do those, please, I encourage you to. It's a little tricky to do in your head. I believe I'm right about those. All right, so here's what I'd like you to do. Go ahead and look at problem number 2. It says, example number 2, find the common ratio and use r to find the next 3 terms. I'd like you to go ahead and pause the video and give this a shot. All right, so see if you can figure out what the common ratio is, see if you can figure out the next 3 terms, and then come back. So pause the video, give it a shot. Okay, so hopefully you just tried this on your own. So it wants us to figure out what the common ratio is and then the next 3 terms. So in this case, if I took one of the later terms and divided by a previous term, 20 divided by 5, well, that's going to give me 4. So let's double check that. 5 times 4 equals 20. Yep. So I know that my common ratio is going to be times 4. Let's double check. 20 times 4. Yep, that equals 80. 80 times 4. Yep, that equals 320. So my common ratio is going to be times 4. And then for the next 3 terms, that's where it gets a little bit tricky. So 320 times 4, it's going to give me 1280. 1280 times 4, oh dear, gives me 2560 times 2. 5120. And then my last one there, 5120 times 4, that's going to give me 20,480. And once again, I don't expect you guys to do these in your head. If you need a calculator, please use it. But next 3 terms, 1280, 5120, 20,480. Okay. Let's do one more. I'm sorry, we have 2 more. Go ahead and try number 3. Pause the video, give it a shot. Okay, so this one's a little bit different. So the last 2 we had have been multiplication. Well, this one, you'll notice it's not multiplication because it's going down. So let's see if we can't figure it out anyways. So let's go ahead and take 50 divided by 100. So 50 divided by 100. and you notice that you're going to get 0.5 or 1/2. So there's two different ways I could write this. I could say that I'm multiplying by 0.5, which is what I'm going to encourage you to say because I think it's going to be easier for you. The other thing that you could say is that you're dividing by 2. Either way, it means the exact same thing. You're either multiplying by 1/2 or you're dividing by 2. So I'm going to say I'm multiplying by 1/2. So times 0.5. And I need to figure out the next 3 terms of this sequence. So let's double check my math real quick. 100 times half, yep, that's 50. 50 times half, that's 25. Like I said, you could also say 25 divided by 2 is 12.5. So next one, let's see, 12.5, oh, I have my comment. My comment is going to be times 0.5, or you could say divided by 2. Whichever one you want to say is completely up to you. They're both completely acceptable. So in this case, like I said, I'm going to highly encourage you guys to get used to the times 0.5. Okay, so 12.5 times 1/2, well, that's going to give me 6.25. 6.25 times 1/2, that's going to give me 3.125. And then 3.125 times 1/2. Oh dear. Let's see. We're just going to say that that's 1 point. I need a calculator. I think it's 51625 or something like that. All right, so let's do 3.125 times 1/2. Yeah, 1.5625. All right, so when it says what are my next 3 terms, I had 6.25, 3.125, and 1.5625. All right, it's going to make more sense in a little bit why I'm telling you to figure out the multiplication rather than the division on this. Just kind of trust me on that. Go ahead, try number 4, give it a shot. Please pause the video, see if you can get it. Okay, so let's go ahead and take a look at this one. You'll notice, once again, this one's going down. So let's take one of the later terms and divide it by one of our previous terms. So I've got -3, and then I've got 9. So if I take -3, divide that by 9, I'm going to get -1/3. So -1/3. If I take 1 divided by -3, I'm going to get -1/3. All right, so each time here, what we're actually doing is multiplying by -1/3. So our common ratio is going to be multiplied by -1/3. And for the next 3 terms, -1/3 times -1/3, if you put this in the calculator, it's going to be 1/9. If I times that by -1/3, that's going to give me -1/27. And if I multiply that times -1/3, multiplication here, that's going to give me 1/81, if I'm doing my math right. That's my next 3 terms will be 1/9, -1/27, and 1/81. All right, so not too bad. You guys should have been able to figure these out fairly easily. We've got one more page to go. We've got 2 more examples. So go ahead, go down to that last page. It says geometric sequence on top, and it has the formula. Right, so far, we have just figured out what the pattern would be. We haven't actually created the formula. All right, so here's what I'd like you to do. Somewhere on your paper, I just want to get you used to writing this. Let's copy down this geometric formula. So I've got f of n equals f of 1 times r raised to the power of n minus 1. All right, so we've got a lot going on there. I'm going to go and label this. I know we did it before, but I'd still like to go and label it again. F of n, that's the term defined. All right, that's the one that we're trying to find. F of 1, that's my first term. And then r n minus 1, remember r is going to be our common ratio. So let's see if we can try a couple of these. So example number 5, it says create the equation that describes the geometric sequence shown. And it's got 5, 15, 45, and 135. All right, so it's got, it says, what is f of 1? So f of 1, remember all f of 1 is our first term. So f of 1 equals 5. All right, and it says, what is our r? All right, so let's go and calculate this. What am I having to do to each term to get the next one? Well, you could take a later term and divide it by a previous term. So 15 divided by 5, that would give me 3. And so my ratio in this case is I'm multiplying by 3 each time. All right, so r is going to be 3. Okay, and then last it says, what is my equation? All right, so the equation for this one, remember we're going to just use this kind of example up at the top, is going to be f of n equals my first term, which you guys have already put down as 5. That's 5 times your common ratio, so that's 3 raised to the power of n minus 1. All right, so this equation is f of n equals 5 times 3 raised to the power of n minus 1. So it wants us to go ahead and do an example of what is the 7th term of this sequence. So it's really not too bad here. To find the 7th term, we're just going to go ahead and rewrite this. This becomes f of 7, because we're trying to find the 7th term, equals 5 times 3 raised to the power of n minus 1. Now you'll remember when I've got n up here, n is just going to be the term I'm trying to find. Now I'm trying to find 7, so this is going to become raised to the power of 7 minus 1. All right, so my next step here would be f of 7 equals, remember your order of operations, parentheses, exponent, multiplication, division, addition, then subtraction. I don't have to simplify anything in my parentheses, so I'm going to do my exponent next. All right, so I'm going to carry down my 5 times, and then I've got 3 raised to the power of 7 minus 1. Well, 7 minus 1 is going to be 6. That's pretty easy to do. So we just need to figure out what 3 to the power of 6 is going to be. That's going to be 729. All right, so I've got 5 times 729. So f of 7, my final answer is going to be 5 times 729, or 3,645. That's it. So you'll notice a couple of steps there. First thing you did, I went ahead and labeled my first term, labeled my ratio. I went ahead and made my equation, and then I found what they're asking me for, in this case, f of 7. All right, so here's what I'd like you to do. Please go ahead and try problem number 6. Pause the video, give it a shot, then we're going to come back and talk about it. Okay, so in this case, it's got the equation 144, 72, 36, 18. I'm sorry, it's got the sequence 144, 72, 36, 18. All right, so my f of 1 in this case, my first term is going to be 144. My r, so if I go find a later term, so find one of the later terms, divide it by the previous term. So 72 divided by 144. My common ratio is going to be 0.5. All right, so each time I'm multiplying by 0.5. And then it wants me to put that into an equation. All right, so my equation is going to be f of n equals f of 1, which in this case we know is 144, times my r, which is going to be 0.5, raised to the power of n minus 1. All right, so it's really not too bad. If you can remember this equation up top here, then really all you have to do is plug in your first term, plug in your r. Be right back. Sorry, I have an alarm going off. All right, so the last thing it says is what is my eighth term going to be? So if I do f of 8 equals 144 times 0.5 raised to the power of 8 minus 1. So if I go to my calculator, I've got, let's see, so I'm going to do my exponent. 8 minus 1, that's going to be 7. So it's going to become 0.5 to the power of 7. Now let's see here, and it says to round to the nearest hundredth. All right, so rounding to the nearest hundredth in this case is going to be, this is going to give me 0.01. All right, so I've got 144 times 0.01. So my f of 8 equals, I believe it's going to be 1.44, but let's go ahead and double check it. Yep, 1.44. So f of 8 equals 1.44. All right, that's it. So find your first term, find your ratio, plug it into the equation, and just see what it spits out. All right, so thank you guys for sticking with me on this. I have a practice Kahoot that I'd like you to try. So if you go to the Google Classroom, go to the practice Kahoot. It's 10 questions. It's a really quick one. It'll just kind of get you used to looking for common ratios. If you have any questions at all, please don't hesitate to contact me. I will see you guys tomorrow. We will have a quiz over this. We'll do a quick review tomorrow before the quiz, though. All right. Hope you guys enjoy the rest of your virtual day. As always, stay out of trouble, stay safe, have fun, and I'll see you guys on the flip side.